all we covered. I mean, I myself, I had to go back to listen um, to watch it, and it was kind of productive. I can attest to that. Like every concept about how the um, compiler works. So we are going to be starting with this. Everyone should just concentrate and fix up their mind on every concept here. You know, one thing I'm trying my best to do, and as we are learning in this thing, is actually giving. I'm trying to make sure that we the right concept, like the fundamental concept upon which every other thing is built upon, okay, making sure that we get familiar with them, knowing what this term means, knowing what it does, so that when you now come to across every other ones, different ones, it will be easier for you to really know what is happening. One of the problems and bridge in understanding is that sometimes we get exposed to some concepts which were actually, if we look at it technically, they were not the ones we ought to get exposed to first in the first place. So the ones that ought to be like the basic one, like knowing what this thing does, probably the one that we are being exposed to in the first place, it is like the outcome of a particular basic knowledge which was not there. So there will be a lag, although there are ways of learning, like patterns of learning in that manner, which could be very effective. But as it is, if a particular pattern of learning is implemented and it is not implemented effectively, there will be bridges and gaps in knowledge, and that is what will cause sometimes getting frustrated with something. So all of these concepts I want to discuss in this slide, they will serve as building block and fundamentals for everything that we're going to see later regarding this section of if else and variables um in C. And like so we will what continue building up like so. So constant in C. Okay, our previous class, our sessions, we briefly talked about variables and constants. If I do a quick review, we already know what a variable is. Anything that has a name and that can what hold a value. Okay, variables are mainly known for what storing values of different type, and we already know C programming language to be a language that is what when there's something called statistically type. Why I mean a language that is very, very, very strict with whatever variable you use or whatever type of variable you use. It is very, very strict with its data. If you know that you want to write a program that is going to perform anything, C is expecting you that you should know what type of variable, okay, what type of data you are going to what store in that variable, ensuring that you know why you are using it, because every type of data used in C, they have the amount of space they occupy in the memory location. And one of the advantages of C language is that the ability to manage the memory is one of the things that makes it to be fast and efficient and portable. So in the sense that because a lot of programs they are very slow, a lot of programs they encounter issues in the process of execution because of what the ability the issues of memory management. But C is very what flexible and efficient when you want to manage memory. And when you talk about memory is just like okay, a space where something can be stored. So when you know how to manage your space very well when you are performing a task, that makes you to be flexible, efficient, and fast and different from every other thing. So now constant in C. Constants are identifier, anything with a name, but they have fixed values. just like how we said it the other time. That is, their values do not change throughout program execution. Of course, in the field of mathematics, we have some values that we know as to be constant for calculating something, constant value for a particular what, a thing. For example, when you go to the field of circle, you want to calculate, when you talk about pi has a constant value of 3.14, and some numbers, and so other numbers. This is just like rounding it off. So, or you use the fractional value 22/7. So it is constant everywhere throughout the world, that pi is known to be 3.143, and so on. So what we are trying to talk about is pi constant. They have fixed value, their value does not change. Now they are now what we call constant in C. Now this one now is now different from, it's still the same thing that okay, these things, they do not change their value. But what we mean by this is that there are some data that this is how they are, and this is how they are being used in C, and they do not change in terms of their implementation. So this is what this one is talking about. So the first one is we have numeric constants, and numeric constant is further divided into two, where we have integer and floating point or real numbers. And then we have character constant, which is further divided into two, where we have single character constant and string constant. Now, this is telling us that when we're talking about numbers, or when we are talking about characters, if we are talking about numbers, there are majorly just two constant type of numbers in C. That is, if you are if you are dealing with any program whereby you are to use numbers, they are just basically two numbers of a particular type, two numbers that are in C, which is, it can either be an integer. That number you want to deal with can either be an integer, or it will be a real number or a floating point number. So integer are numbers without decimal point. Floating point numbers are numbers with decimal points or fractions. Okay. And now character constants, we have a single character constant, of which we have used many times, even in shell, whereby they are enclosed in what? Single quotes. And then we have string constants, of which they are what? Combinations or sequences of characters, single characters, and they are enclosed in what? Double quotes. So single character constant enclosed in single quotes, string constant enclosed in double quotes. Now when we go to categories of integer constants, now this is where, if I was saying something that I will try to create a slide to talk about number system or numbering system in computer science and in C, because they will guide and help us, give us some understanding. But let's just keep it this way. Categories of integer constants, we have octal constants, which is base 8 and ranges from 0 to 7. And we have decimal constants, which is base 10, which ranges from 0 to 9. And we have hexadecimal constants, base 16, which ranges from 0 to 9, and then A to F. That is 16, we can just say 0 to 16. But when you are writing it, you will have your normal numbers from 0 to 9. And then when you get to 10, you won't write 10, because you are dealing with hexadecimal, which is 16. Then your 10 will be replaced as alphabet A, and up to what? F, 15. And when you count from 0 to F, if you count all the numbers in the single-handedly, they will give you 16 bits. Okay, that is why we call it what? When you say bit, a bit is a single number, that is 16 different individual numbers. Okay, so That is why we call it hexadecimal. So categories of integer constant: octal, base 8, decimal, base 10, hexadecimal, base 16. All these things is just okay. These things exist. Let us know what they are. When we get to some part of explanation in order to break down a particular concept, we already know what these terms are, and it will be what easier for us to digest. Now, going to the other part, categories of real number constant or floating point constant. We have floats and then doubles. Remember, the integers, they don't have fractions, they don't have decimal places. But the real numbers or floating point, they have what? Decimals, they have fractions. So, that's why they call them real numbers. That is, in reality, decimals can happen in arithmetic computation or operation. Okay, so now moving forward, now let's now talk about character and string constants. When we talk about single character constants are constants that have a single character enclosed in single quotes. Okay, so single character constant, they have a single character enclosed in single quotes. For example, you have single quotes of A, single quote capital A, single quote of small or lowercase a, single quote of lowercase s, a character. So if I talk about, if I want to look for, definitely we already know that um, whatever string of words that is being formed, they are what all combination of single characters. You can see individual characters. So creating a single character constant, they have to be enclosed in what? Single quotes. That is just the explanation. That is enough to understand. So any single character enclosed in single quotes are all valid. Okay. So in C, every single character have either number value and meaning according to the ASCII standard values. Now, ASCII is short for American Standard something. I don't I've not crammed the meaning, but it's actually like it's a standard. Okay, it is like a general standard, or we call it a body that is responsible for that defines the rule on how you use single characters in C programming language, and probably generally all the programming language. Okay, so they have a list of different what characters, and each of them, they have their values in hexadecimal, decimal, and let me open this and so that we can see what I'm talking about, just to quickly um, establish the understanding of single character. So if I do man ASCII, okay, we are talking about single character. Okay, so you can see the ASCII character set encoded in, you can see octal, decimal, and hexadecimal. This project that was released yesterday, if you have kindly just gone through it to scan it through, you would have seen that at a particular point they were saying that you are only allowed to print a particular um, um output using putchar alone. You are not to use printf. So all of these things, putchar, printf, and all of them, they have the standard output that they can what give. So on a normal day, there are two types of outputs that can be generated on in using C. Okay, there are two types of output that can be generated in a technical on a normal day, and it can either be a formatted output and or an unformatted output. So generally there are two types of outputs that can be produced. It can either be a formatted output or an unformatted output. When you say formatted output, I was explaining yesterday, when you say formatted output means that that output that you want to print, that string of characters or single character or whatever you want to print, you have dominion over it such that you can specify it explicitly the way you want the output to be. And a very example of what function can do that is the printf function. Printf function gives you the liberty to explicitly define the way you want to print your string of character or numbers or anything. That is why they call it a formatted output. And when you now talk about unformatted output functions, example is the putchar, of which it has a defined rule of the way you can what print your output, and you have to what succumb to the rule. It is the unformatted output function that will determine the way that output is to be. Now the ASCII is one of the way to understand some characters and how they what they mean. When we get to this, I will actually still break them. But one thing I want you to understand is that the ASCII values set of characters that can be printed, okay, and they appear in octal mode, decimal mode, hexadecimal. So that is, if you are printing in octal mode a particular word character, a particular number, it has its what meaning or value in what character it is going to print. So going back to where we are, the single character constant, just know that they are enclosed in single quotes. Now, they have ASCII standard, of course. When we get there, you'll see how this thing work. Now, for example, when you talk about uppercase, from capital A to Z, they have their number, the values in ASCII, which is 65 to 90. If you are printing a character, for example, let me practicalize this. Let me say I want to print, okay, excuse me, excuse me. Okay, so if I say to print numbers from 1 to, from 0 to 9 using characters, okay, let's say using character constants. Now, I can define a character as char c, okay, and I can do something like, and then I'm using only putchar function. Now I can do something like this. Excuse me. So I can do something like, um I can do putchar. I can just do now. Putchar is a function for printing just characters, single characters, and is receive just only one value. You cannot. It receive only one value, and if it can receive number that is integers, but if you want to print anything in quotes, it receive only single quotes. Okay, you cannot put double quotes, and you cannot print with double quotes on putchar. So it is mainly for characters, single characters. So I can say I want to print 0. Now if I put like this 48 inside putchar, Putka is going to look for the value of 48, the ASCII value. So it will look up, it looks up for the value, the ASCII value of 48, okay, and then print the result. So don't, this is necessary. 48, of course, this is a decimal. This is a decimal number, okay, because the range here, this is 4, and the range here, this is what, 8, okay. So combining, decimal involve number that ranges from 0 to 9, okay. So combination of any number that the combination is from just between 0 to 9 is a decimal, okay. So it will look for 48 under the ASCII standard table, okay, and then the equivalent value in character, because what data that the data we defined here, the kind of the data type that we defined here is a character. So it is now going to look for equivalent value of 48 in the ASCII table and print the data. So that is just like the logic here. Now, if we go to our man page and under decimal, okay, and we try to look for 48, so this is 10, and we look for 48 under the ASCII table. Now, this is 48. So remember, the final one is where the value is. So now 48, the value, the character value of 48 is what? 0. So obviously the output I'm supposed to receive should be 0. And if I run this code and I run it, you can see it's what? It gave me 0 as the output. Now, probably that is not clear enough. If I should put another number, another value, let's say I put like 66. Now, Putka, remember, it only works with characters. So what is it going to do? It is going to look for 66 in the ASCII table and then give out the value, the character value, the equivalent character value. Now, let's check our mapping. If we look, that is, we wrote 68. This is 63, and it continued to this point. Now, we will now see why at some point we will get to understand why we are having numbers from 0 to 60 something like this. We'll see what they are. Now, look at this is 68 in decimal, and the equivalent value is what? D. So, obviously, okay, 66. This is 66, and the equivalent value is B. So, obviously, it should print B like this. If I run it, and you could see the output here is what? B. So this is one take home to understand about character, character constants. And when we are talking about which of the character constants, single character constants. That is why we give example here. You can see in uppercase, they have their value, in lowercase, ASCII standard, and numbers from 0 to 9, which was 48 to 57. If you look up the ASCII man page, this is about single characters. This is just necessary to in order to prepare us to where we are going. Now, even for special characters and so on, they have their value. If you look at special characters, if you are talking about null, um probably, or a new line, you can see if you print 10, it means you are saying you want to print a new line. Let's say, let me practicalize it. If I print 10, just 10, if I print 10 multiple times, then this will provide a multiple new line. And you should observe where the cut, and let me print something at the last one. Let me print 50. and you will see what will happen. Can you see the position of the output? So all the new lines ran from this top and what? The equivalent value of 50 in character. Okay, the equivalent character value of 50 in the ASCII table was 2, and it gave what? 2. And this is what we are talking about. Remember, Putka received just a single character. Now, if I can print a single character in quotes. I can print A, and of course, it will give me A as it is, as the value. So if I print A like this, it is going to give me A. I can only print these characters one at a time using Putka. Okay. Now this is all about. So now some the functions that can always print this single character is Putka and then put ch. When we get to all of this, we will cross the bridge. Now printf too can print. Please don't misquote, because printf can virtually print almost anything. So if I say I want to print single character with printf, I can now use printf. I can say, because printf will be in quotation mark, and if you look at the synopsis here, it said constant character. That is, which character constant are you printing? Okay, now if I say percent %c, that is, I'm giving the format specifier of what I want to print, and I say it should print. Now let me use a number. Let me say um let me say 50 55. Now what should be the output? Normally we'll be thinking it's going to print 55, but it will look up the ASCII value of 55 on the ASCII table and then print the equivalent character value. So if I run it, can you see it gave me A7. Now this A is coming from the putka, and now 7 is coming from the printf. This happened like because we didn't specify a new line. So let's use the putka to print a new line. We can do putka, and remember single character, you can say new line. So these are constants. That's why they call them constant. They are already there. They are being on the standard of the ASCII, and this is just how they are and how you are to use them. So if I print, can you see now that the seven has dropped down because I have indicated a new line, and this 7 is coming from the printf, and the value of 55 on the ASCII man page, 55 on decimal 55 is what? 7. Can you see? So it's 7. Okay, guys. So now that is just for characters, for single characters constant. Now there is the other type, which is what? The string characters. Now before that, you see, in single character constants, arithmetic operations are also possible with these characters. For example, printf %d a, this will print the integer value of a. Now I can do something. Let me just introduce something. Even as I'm printing, I can print, for example, imagine I say, let's define another character. Let's say car d. Okay, let's set d to be equals to um let's set it to be equals to c, capital C, right? Look at what we have here, capital C. And I can do putka, okay? And I can do putka, it should print D plus plus. No, okay, D plus plus. Okay, we'll explain what this means. And I can do again putka. I'm going to do putka D plus plus again. Now, the expected output from here is I'm going to have capital C here, and When I run this, eh, I'm going to have E instead. Now, if I do something, if I do put car, if I do put car D at this point, this is when the plus plus will now what will be applied. Something is going to happen. At this point, I did put car D plus plus. So I'm going to still have C. If I do put car D again this time around, I'm going to have D. And if I do put card D plus plus, I'm going to have E. Let's see if my assumption is correct. Okay. Um, let's print a new line after each of them. And a new line here. Put car. So that for this new line and this for this. Let's see if my assumption is correct. So put car. So normally you can see the value of D, the variable D was capital C. Okay. So we have, let me print a new line here. Okay. So what is our output? Let's see. For the first put car D plus plus, we add C. Okay, a new line. Okay, the second put car D. Okay, it gave what? It gave D. Can you see? And I was correct. Okay, now this one put car plus plus. Okay, it will always give D because sorry, it should be D. Now, what I'm trying to say is, what is happening here? What is happening here? This is a mathematical operator plus plus. Put car D was incremented. They call it incremental operator. This D, this is D. The value of D initially was what? C. And we now say increment what? D. That is, you should do something, you should do, you should do D equals, you should do D equals D plus 1, of which it is going to be, what is the value of initial value of D? C. If we had 1, that is, you are like stepping forward, and after C is going to be what? D. But the way this man works is that initially it will not give you the output. It is when you use it again, it is going to give you the output. That is the increment. Now, let me take away this. Let's do something. Let's say put car B, Abi. Okay. This is supposed to give me C. Okay, because I'm printing D directly. Now let's do something. Let's say put car um plus plus D. Now, sorry, let's add that new line. Put car new line. Okay. So this man, the output from here is now supposed to give me D. That is, from here I printed this man correctly, which is C. But now this man, this is another type of increment. I am saying before you print anything, increment this man, move to the next step of the value of this, whatever is inside this variable. And what is inside is C. So moving to the next step is giving what? D. Now, let's just see. This is an arithmetic operation that can happen. If I run this man from this line, we have what? The first one, we have C was printed. And that is what, according to the value inside here. Now, for this second line, D, we said put car plus plus D, and it's saying it is like it is giving it is moving to the next step after C. It is incrementing the value, the actual value of D. The actual value of D from here is C. So when you now say plus plus D, it's saying D plus D equals D plus 1, which is going to be like move a step after C in alphabetical order, which is going to be what? D. Now, this might be somehow confusing and not clear enough, but there's a possibility like this with
Yes,
what?
please explain it again if you don't mind. Plus plus
Oh,
D and D plus plus.
okay. I'm not even supposed to quickly go there, but because there is a slide specially for that, which is called increment and decrement operators. Okay. Now, increment operator we is increment operator. We have two types of increment operator, which is could be either which is plus plus, that is increase increment plus plus, and then decrement, which is minus minus from the word decrease. Okay, minus minus from the word increment increase, which is plus plus. It is an operator. That is the standard name, and this is how it looks like. Now there's now what we call postfix and prefix, which in other words mean after and before. Okay, now when we now say postfix increment, this we are now trying to say this means let's for on a variable, let's use on a variable, let's say a. This is what we call postfix increment, a plus plus. When we say prefix increment, and then this is what we now say plus plus a. Now what will happen here, what is going to happen here, this will increase the variable only after it has, let me put it down please, let's say a plus plus so that you can still follow along. This will increase the variable only after the initial value has been printed first. Let me use it that way. Okay, this will increase the variable only after the initial value has been printed first. So, e.g., to make it clear, if we say 10, a equals 10. If we now say a plus plus, at first point of execution, first control point, a will still remain, a will still be equals 10. But at the second point of execution, okay, a will now be equals 11. A will now be increased. That is about postfix. That is after you have really executed the initial thing that is inside that variable. When we now talk about prefix increment, which is plus plus a, this is saying plus plus a. This is saying increase this variable even before you use it. Okay, so if we have plus plus a, it is going to now say this will now give what plus plus. Okay, let's say a equals 10. We now do plus plus a. At first point, this will first execution, this will be a will be equals to 11 directly, and that is like this the slight difference that happened here. Remember, if I do something, look at this put car. If I say put car g plus plus at this point, d plus plus. What is going to happen? The value I'm to get will, of course, it is going to be c. That is, let me use this word. It returns the actual value inside the variable at this time. Okay, first execution. Okay, let's just use that word to explain. Now, if I now say put car, let me add a new line first. If I now add a new line and I now want to print that value of what? If I now say put car, this time around without plus plus, I now want to print d. This time around, the value of d, what? This time, the value of d has been increased, and I'm to get what? C, d, sorry. So this one, I said it returns the actual value inside the variable at this time, and this is the actual value is c. So at this point, when I now print d again, this time the value of d has been increased, and it is going to be what? Capital D, according to what is inside. Probably because I'm using d. Let me use x here, please. Let me use x, so you can, it won't confuse you, because of course after it increase the value will be d. So look at now, we have car x equals what? This character c, single character, capital C to be precise. Now if I do ordinary print car x, it will returns the value that is inside what? The variable x, which is what? Character c, capital C. Perfect. Now a new line. Now we now come and we now say put car x plus plus. What is this saying? It is saying, of course, we are incrementing x, that is, we want to increase x, but because it is a postfix increment, okay, that is, it will only increase after this man has been used, okay, as that means it will only increase this man when after we have used it the first time. It is only increase it when we are using it the second time, okay. It will only increase this value when we are using it the second time. So at the first time that we are using it like this, it is going to return the actual value at this first execution, and the actual value inside x is what? C. We come to a new line and we now say put car x. This time we didn't even specify plus plus. It is going to what? Now return the incremented value of x, that is, it is going to increase x this time around. So this time the value of x has been increased, and what is the value inside x? X is just a variable c, and when c is being increased by 1, okay, so let me put it that it has been increased by 1. That is, when we use all these plus plus, increment or decrement, it's only increased whatever value by 1. So when s has been increased by 1, then the value will now be what? D. And because s is what? C. I don't know if this is clear. Now that is for prefix increment. Now there's another one, this one that is now here. Post that is, sorry, this that we explained here is for postfix increment. Okay, postfix increment. Okay, now if we now do this one, prefix increment, this is saying increase the value of x immediately by 1, even before, okay, by 1 at first execution. I think this makes sense. So at this point, it will automatically give the value of x to be d without wasting time, because what is inside x? C. So it will just increment what? X directly, instantly. If this is not clear, this is just an overview. Let's just take this man this way. So if I run this code and let me run it, and we are going to check them according to the line. So if I run this man, now we are going to see the output. Let's cross check. Look at the first C that we have here. This is coming from this putcar X and it returns C. Now, when we now add a postfix increment, we said X plus plus. And at this point, it has what? It still returned the actual value of X, which is still C. But in the background, when we try to, if we try to use X again, X has been increased, which happened to be here that we now say put X this time around without even a postfix operator. So it now returned what? D at this point. Can you see? So when we now implemented it, so that means at this very point, X is no more C. It has turned to, it is now D. So we now even apply the prefix increment to it, which we now say put car plus plus X. In fact, at that position that X is, which is currently holding the value of D, it has increased it to E. So even at this point, it's not E anymore. This will only be B if all this process above has not happened. Whew. I don't know if it's clear, but let's just take that.
It's clear.
Okay. Okay. Now, you can see all this magic happening with just single character, single character constant. This just know that there's a possibility like that. Fine. Now, when we move further, it will become more clear. Now, let's go to what? String characters. String characters simply refers to sequence, okay? Sequence of characters enclosed within double quotes. They are called what? Strings. So strings are just sequence of characters enclosed in double quotes are called strings. So example, when you have this word Michael in double quote, it is called a string. So Michael string, Joy string, ALX string, software string. Even you can see that this is just a single A, but it's enclosed in this double quote. So A string, 1, 2, 3, 4, 5 strings. So these are what? Strings, which are what? Sequence of characters enclosed in double quotes. So the difference between a string and a single character is by what? Double quotes. Now, a string or string literal, ordinary like this, we call it a string literal too. When you say literal, like a normal a literal string, I don't know what word to still use to explain, but a string or string literal can also be called an array or list, okay, of single characters. This, in a technical term, programming term, this makes sense, makes more sense. That is, it is a list of single characters. Now, there's a concept of array. When we get to array, having a foundation on this understanding will make array more easier. Okay. Now, a string can also be called what? An array or list of single character. You can say an array of single characters or list of single character. And what does this mean? That is, each individual characters having an address location. Okay. For example, when we see a variable called name and it is having the value of a string called joy, the computer is going to read this variable name like this. It is going to read it like a separate characters. where it is going to be J is a separate entity, O is a separate entity, and Y is a separate entity. Still telling us that each of these man here, they have different position in they have different position, okay, in sense that this is in position. And now array index, okay, or counting of a list of characters or a list of anything in programming, the counting start from zero. Just like, when we say we want to count numbers, it start from zero. So anything in programming or in the computer, it start from zero. Okay, so this position, this is telling us that n, the list joy, J is standing in position 0, O is standing in position 1, and Y is standing in position 2. Okay, so normally, what is the take home here? Understand that a string is a sequence or combination of single characters. So if you have multiple characters joined together or enclosed in double quotes, forming a string, computer is going to read them individually, that these things are separate children. Normally, we are going to see them as a single string, but computer is going to read them as separate children. That is telling you that each of the characters forming this string, they have different number, and they stay in different position. Okay, so now it look at this, it reads it like an array, that is the list of separate characters. That is, J is separate, O is separate, Y is separate. This means that each element in the array are characters forming a string. Okay, individual characters in an array are referenced are referenced using an index which starts from 0. What am I trying to say? Like I said, that the counting of individual character in an array, it starts from 0. So this is 0, 1, 2 in this case. So therefore, we can put to each character saying n, n0, okay, is what? J. N1 is what? O. N2 is what? Y. Saying that n at position 0 is J, n at position 1 is O, n at position 2 is Y. This knowledge, just know that there is a possibility. We won't go more than this for at first, at this point. There's a possibility. Now, that is why, when we are looping through a list of entities, okay, for example, when you are using loop actually what? It performs operation on individual characters one by one. That is how it performs its operation on individual characters. So just understand that, fine, we can have a string of characters which involve combinations of different characters forming a single entity, but the computer is going to interpret them like an array. That is, these things are separate entities, and each of them, they have their position, or they have position and location, okay, in the list. So they are staying in different position. As in the example that we had, the variable is n, and it is storing the value joy inside of it. But at this point, we could see that n at position 0 is interpreting J, n at position 1 is interpreting O, and n at position Y is interpreting um, n at position 2 is interpreting Y. Sorry about that. So now the next point say, now there is something C does when it is going to print a string to the screen. It uses a method to detect or to know when it has gotten to the end of the string, that is the end of the characters array. Now, C achieved this by adding something called a sentinel character, which is this symbol here. Okay, excuse me, I can't even find my mouse again. Okay, it uses something called a sentinel character, which is this symbol here. And this man is inside. If you look at our ASCII table, this man, it has is the symbol is there and it has a meaning. Okay, this is an additional character at the end of the string. This is popularly known as the null character. In ASCII, the value of the character, okay, is 0. Okay, and this detects that it has gotten to the end of the string. This knowledge, this concept, just for a basic understanding, just for foundation. Okay, just know that these things exist. So what are we trying to say now? Normally we can see only three characters here, Joy, but in the background, behind the scene, the computer is actually seeing 4, because since Y is the last value, then there is something that will be added for the computer to stop printing this man, and that is this null character that is what appended to it. So normally the computer is going to see that this is it is involved 4 characters, which is going to be Joy and the null character, and it is going to interpret it as N0, N1, N2, N3. At position N0 we have J, at position N1 we have O, at position N2 we have Y. Now, it is always good because this thing will become clear when we go to string, when we go to looping strings, when we go to looping characters. Okay, it will be necessary because when we want to target that a loop should stop when it gets to the end of a string, it is this null character that is used to specify that operation, that instruction. If you want to instruct a loop that it should stop when it has gotten to the end of a string, probably you are looping through a string, it is this null character that will determine that. Okay, this is just a foundation. What is a string? Sequence of character enclosed in double quotes, and computer basically sees it as a list of single character or an array of single character, of which they are indexed from 0, of which their counting start from 0. That is, it count them individually, and each individually that it counts them, they have position from 0, 1, 2 till the end of the string. Foundation, just get the understanding. Now let's move. How do we declare constant in C? There are basically 2 methods for declaring constant in C. All these things we will still um all these things we'll get to understand it. First, number one is using the const keyword. The const keyword is the first method to declare constant in C language. The const keyword is used to declare constant. Okay, and this is the general syntax where you have consts and then the data type and then the name of the constant you are declaring and then the value. So example, we could have const, a character constant with the name. Okay, with the name of the constant is going to be name. And you see this man here, we will understand it later, but this is just saying that it is reserving space. That is this variable here. eh? let me use let me just touch it small. It is saying that this variable here can only receive 20 characters. So 1, 2, 3, 4, 5, 6, whatever you put here, it can only receive 20 characters. Can you, if you have tried to fill a form before on the internet, or if you have tried to um do something before on the internet whereby you have to type something, Probably a simple example is your status, your WhatsApp status. If you are trying to type something, at some point when you type to a particular point, you it will tell you that you have exceeded the maximum amount of characters that you can put there. Or let's use Twitter. Bounty level. Let's use Twitter. If you use Twitter, there is a maximum amount of what characters that you can type. Normally, we interpret it as maximum amount of words, but the computer will always work with character. So, a maximum amount of character that you can type before you see the red signal that you have existed. So, this is saying that for this variable name, it can only what receive 20 maximum amount of character. When we get to string itself and declaring string, looping over strings, this will become clearer. So, not to digress too much, declaring constant in C, you use the what? The const keyword. We can use the const keyword, and this is the general syntax, the way it looks like. So, after the headers and comments has been declared, okay, I'm just using that. Now, that's why you can have, okay, something like this. You can say const. This one is a constant number, const int, and the name of the what the constant variable is a, and we said is equals to 10. So an integer constant with name a having value of 10. The second way to do this is using the define what keyword. As regards convention, the syntax defined in this method are usually uppercase. Okay. So when you use the define keyword, it is going to be like this: define name of the constant and then the constant value, which we have define max, that is the name of the constant, and then the value is 300. So hash define is a macro, so we call it a macro too, using macro to define constant. So the first one is using the const keyword to define constant. The second one is using the macro hash define to define constants. Okay, let's move on. So variables in C, anything that has a name and a value is a variable. In C language, variables are their value stored in a memory location. They are identifiers. Okay, variables are identifiers which hold values of different type in the computer memory location. Unlike constants, whose value doesn't change, variables value can change during program execution. Okay, so general syntax to declaring variables in C goes this way: the data type, the variable name, and what the value. And this is an example of a variable that has what that has been initialized, given a value. So when you declare like this, you are initializing the variable already. And when you declare in this second way, where you have data type, variable name, just like this is an example of declaring a variable that is only declared, but it is yet to be initialized. That is, you have not given it a value. Moving forth, variables in C. Now, the ways you can, the acceptable ways of declaring variables and initializing variables in C. You have int A, example like this, an integer variable only declared. Okay, that is all the types of variable. We can have an integer variable which is only declared, and at this point it is initialized. And this one, it is a character variable which is only declared, but at this point now we now initialize it. An integer variable which is declared and initialized at the same time. Okay, um this is declared and initialized at the same time. This one, a float variable which is declared and initialized at the same time too. And this one, we can declare variables in this way too. You can declare three
Can anybody hear him? I can't hear him. Oh. Can anyone hear him?
I can't hear as well.
Let me call him.
Oh, okay, okay. Jesus. Okay,
We can't
you
hear
can
him.
hear. How long have you not been able to hear me?
Before you left to variable something something.
Okay. Thank you for um, thank you for the observation. Okay, could you hear me while I was explaining these
Yes,
variables?
yes, yes. The next slide.
This one you couldn't hear me when I was talking here. Okay.
Mm.
So keywords. What are keywords in C? They are just like special words which have special meaning. As simple as that. And they are actually used. They serve as the building blocks for writing program codes. You know, in English language, we have letters and alphabets, you know, and all of them are what joined together for us to write sentence. Okay, the same thing applies to keywords in C, whereby these are the words you use to form your logic and to write your program. So there are basically 32 keywords in C. Okay, so example of them is this: int, float, break, go to, if, for, while, continue, do, switch, auto, double, and so on. There are many like that. So there are 32 in number. So you just need to understand that there's what we call keywords and reserved words in C. Now, coming to this very part, data types in C. Data types are needed for holding different types of value of data in memory. We have different type of data. Normally, if you go to computer science or normally information, like you as a person, you want to write your name, there is a particular word that is a data. Okay, writing your name is a data, a name of a person. Okay, the way you write your name, the string you coin together, that is a string. Okay, a data, characters, you join characters together that forms a meaning to form your name. That's a type of data. When you want to write your number, phone number, that is the type of data. When you are writing punctuation marks and special symbols, that is a type of data. When you're writing numbers that involve decimal places, that is a type of data. So C is very intelligent that since we have different data like that in the world, there should be a way of storing them. There should be a way of categorizing them. So that is why data types are needed for storing different types of data in memory. Each data type have specific amount of space they occupy in memory based on that type. Okay. For every data type, it is equivalent. Okay, for every data, okay, for every data, its equivalent data type is needed to what? To store to be stored in memory. If you have ints, okay, if you have ints, as it is that you have ints, it has the amount of space it will what? It will occupy in memory. That is, for a number variable, the data type for number is needed to store that variable. If you are declaring a number variable, probably it is an integer or a float or a double. So in C, as we have said, there is a data type for holding that type of data. The amount of space occupied by a data type or variable in memory is determined by the size of that data type. That is, if you are declaring an integer, integer has its own amount of space it what occupies in memory. And this is actually even based on the machine it is running. To call long story short, we did a project yesterday, I mean day before yesterday, and that project was you should what print the size of types on what on different machine. So that is what they are trying to give to us. That is, for an integer on a 32-bit machine, it has the amount of space it occupies. For a float on a 32-bit machine or 64, it has the amount of um it has the amount of space it occupies. Moving forth, there are basically three categories of data type in C, and this is where it is becoming interesting. So we have primary data type, okay? We have primary data type, which are also known as built-in data type. And example of primary data type is where we have numbers, characters, and then void. So under the numbers, we have explained this over and over. We have the different numbers, integers and real numbers. Characters, we have explained this, single characters and string characters. Now, this one is void. This last one is a special, so it's something new. Okay, it's a special primary data type, which means empty. You have tried to use the main function. You did main into bracket void. So just understand this. There are basically three categories. Number one is primary data type, and under primary data type we have numbers, characters, and void. And then we have derived data type. These are data type that are what? That are built, or that are built, or that are built from what? The primary data type. Okay. Derived data type comes from the primary data type. Okay. So we have arrays, structures, union, and pointers. And the last one, we have the user defined data. Type def and num. Just know this stuff. Coming back, three categories of data type: primary data type, under primary data type, number, characters, void; derived data type, arrays, structures, unions, pointers; user defined data types, example, type dev, enum. Okay, enum is short for enumeration. When we get there, which we'll understand more. Now, this is now this one is necessary. I actually want to dwell on it to actually broaden our understanding and some of the things we have written so far in the project, and it looks like it's not clear. Qualifiers and modifiers in C. Just follow me. Qualifiers are keywords applied to the data types to change its meaning. Simple. Keywords applied to data type to change its meaning. What are we talking about? Example, you have sometimes you could have seen that you have seen somewhere that they declared an integer variable, and you see that they did something like unsigned int. Okay, you see unsigned int a or unsigned int b. That qualifier unsigned is a keyword applied to the what? To the data type int, and in that case it will change the meaning of that data type. As a matter of fact, guys, we are still going to have another session on just qualifiers, and we'll still see what all these things mean. But I'm running through this stuff. Just know that these things exist. This slide, I'm going to send it so that we can still go back and read over it and just probably use it to compare whatever we are reading also, just to give understanding. So qualifiers are keywords applied to data types to change its meaning. So of course, I give an example. You see unsigned float, unsigned int, long int, short int. All these things are qualifiers, and they have different meaning they give to that data type. Modifiers in C language. Now, the amount of you have the amount of memory space, okay, to be allocated to a variable is determined by what? The modifiers. If it is a short, there is amount of space it is going to give to that data type. If that data type is a long, there's an amount of space it is going to give. If it is a signed, there's an amount of space. If it is an unsigned, there's an amount of space. If it is long, there's an amount of space. Now, Modifiers are prefixed with basic data types to modify, that is, to either increase or decrease the amount of storage space they what they occupy. Okay, so modifiers, they are actually used in order to what, to manipulate the amount of space. Of course, we have seen, let me open this. Where is that resource? We have seen this resource. Of course, you can see this. Look at these different types. You can see just ordinary car. See the amount it takes 1 byte. Now look at when you see unsigned car, it still take 1 byte. Now look at this. This is short, and this is actually short int. It takes what, 2 bytes. Look at this unsigned short. Of course, it's still taking 2 bytes. But look at this man, int. It takes what, 4 bytes. And you still have unsigned int, which takes what, 4 bytes. But when you have long int, this is actually for long int, it's taking 8 bytes. And unsigned long int taking 8 bytes. Now this is at the side of what, the size. For car, now 1 byte in storage, and it has the range of 1 minus 128 to 127, because I said something that when they do not specify unsigned, it is automatically signed. So this is a signed car. This is an unsigned car, and it takes 1 byte in memory, but the values of numbers, the type of numbers it can always take is going to be from 0 to 255. It does not have the tendency of occupying any negative value. Unsigned, that is, you can call this unsigned, you can call it no sign, no sign car, and you can call this one sign car, that is, minus or plus can what, happen upon it, can be implemented. Short, now look at something, the amount of size, storage size, and the range of values, minus 128 to 127, the same thing, from 0 to 255. So range of value, look at short, the size changes, it's taking 2 bytes. And look at the range of value, you can see that it differs, it is different from that of what, a car. It is taking 1 minus 32,768 to plus 32,767. That is the range for a typical short int taking 2 bytes, and this is the range. An unsigned short, that is, it does not have any sign, is taking the range from 0 to 65,535. Now guys, I said there's a trick here. If you want to differentiate between, if like to just logically derive the value of a signed data type from an unsigned, so you divide the unsigned by 2. If you divide 65,533 times 35 by 2, you will have these two. That is, if you add these two together, it will give you these two. Okay, so guys, just let's just talk about this briefly, and when we come back to this sign and unsigned, a special slide for it, it will become clear. So but just know that all these sign, yes, and sign car, sign int, unsigned int, and long int, short int, long int, all those things are known as modifiers. So there are 5 modifiers available in C language, and which are short, long, long, signed, and unsigned. And when you have these three, when you have short, is an example of a size modifier. The range, sorry, the size modifier, talking about the amount of what space it will take in memory. When you have long, is talk about the amount of space a long integer is going to occupy in memory. And when you talk about long, it has its own amount of space, the size of space to it will take. Now we now have signed and unsigned, and this is an example. It's called a range modifier, that is equivalent to producing range of the size modifier on different machine. That is a signed um a signed data type that, just like we said, it has positive sign and negative sign, and those are like a division of the size modifier splitted into two. Okay, so having different range from minus to positive. And now unsigned too is the same thing too, of having unsigned now does not have any sign, does not have negative or positive. I mean, it does not have any negative, just positive, and it's range from 0 to whatever the range it is. Okay, the last one, qualifiers and modifiers in C. Type qualifiers, C type qualifiers, and then we have two type of qualifier. We have the const and the volatile. Just let's just understand that these things happens or is exist. So C type qualifiers, these keywords, these are keywords which are used to modify properties of a variable. Okay, and they are called type qualifiers. So type qualifiers are also used to what, modify properties of a variable, and there are two type. We have the const type qualifier and the volatile. Okay, so um let's just let's go to let's come to operators in C, and this is in relation to um the project that was being released. But before that, what we have said so far, let's take a break and then let's try to quickly interact. Is there any clarification somewhere? And I know people are coming in and they are going. People, I will just release the recording and people will go through it. But with what we have learned so far, um, do we have any question or like observation or something like clarification on any? Do we need clarification in any part of it? All we have learned so far. We have learned, what have we learned? What have we talked about so far? We have talked about character and string constants. We have talked about character and string constant. We have talked about how characters work, single characters. Talk about string characters. Talk about declare constants in C. We talk about variables, how to declare variables, and the different ways of declaring variables in C. And then we've talked about reserved words, and then we've talked about data type and giving of understanding of um, the individual amount of space every data type occupy. And then we talk about the different type of data type, that is basically three categories: primary data type, derived data type, and user defined. And we talked about the primary data type, which is divided into three: numbers, characters, and void. And then we talked about derived data type, which is, example, array structures, union pointers. And then user defined, type def, you know. And we've talked about qualifiers and modifiers in C, um, where we explain that qualifiers, they are keywords which, when applied to data type, they tend to change the meaning, and type qualifiers actually affect the properties of a particular variable. So we have basically five modifiers in C: short, long, sign, and unsigned. And they are what, in categories. From the short to the long and long, they are known as the size modifier. And from the signed and unsigned, they are the range modifier. Okay, so before we come into operator, do we have any question, guys? I know a lot of things has been talked about, but one thing that is necessary here, why probably normally all of these sections could have been in separately, one by one, trying to talk about them differently, but we don't have time as far as this program is. So that's why you just need to say everything. That's why they will tell you, they will give you long, many resources just to tell you that you should read everything. Just read through because they just want you to make sure that these things exist, get familiar with them, and the more you keep hearing that, the more you keep learning, the more you gain understanding. So I'm not getting any response from anybody. I think we are good. We should continue to operators, right? Or we should pend it till night. Although I said we want to look at the concepts that are given here so that they can, I think we've talked about even some of them, keywords and identifier integers. So we are in operators, okay? And before we now come to control, the if else. So all these relational operators, logical operators, arithmetic operators, they are under the operator types. The while loop and for loop, they are under what we call iteration. Okay, iteration means repetition. So repetition should occur based on a condition, and then the um, uh, the if else statements are under the concept known as control, controlling the flow of of a program. Instead of a program to just execute like that, you give condition to control the flow of a program. Okay. So are you guys saying I should continue?
Yes, please.
Okay. So now, operators in C. Operators are symbols which tells the computer what mathematical or logical or relational operation to perform. Okay. With operators, operands form a sequence of expression to perform a particular task. So, firstly, let me break it down. Operators are symbols that tells the computer to perform a logical, mathematical, or relational operation. Now, for for an operation to occur, okay, for an operation to occur, they have to be operator, okay, and after there is an operator, they have to be operands that what will perform the operation. So operands are just like the they are just like the, we can call it the variables, or we can call it the entities that um, perform an operation, that are joined together to perform an operation. For example, look at this. We have an expression. An expression is called, he said, expression is a sequence of operators and operands, which gives an output. So if you break down this, an expression is a sequence of operators and operands, which gives an output. Okay, so this is an expression, a equals 5 plus 5. But this 5 here and this 5 here, they are the operand. Okay, they are they are the what we call the operand. Okay, and this man here in the middle, is the operator. Okay, so this should be clear. So operators, it is by this operator that this operand 5 and this another operand 5 was able to what? Perform a computation. And this operator, what type of operator is this? It is an arithmetic operator. And as it is, because of that, it is now saying that you should add what is at my end, my two end, or add the operands 5 and 5, add them together, and then store the value inside A. So that is the basic explanation of this expression. So an expression is a sequence of operators and operands, and an expression would always give an output. There's a concept we have expression, another concept we have statement. So what makes an expression different from a statement is that an expression would always have an output, and an expression is always sequence of what? Operators and operands. But a statement does not actually generate an immediate output. Okay, let's just have that by the side. So operator symbols that tells the computer what mathematical, logical, or relational operation to, to perform. Now, types of operators. There are three categories of operators in C, of which these individual operators could have subdivisions. So there are basically three types of operators. We have number one, the unary operator, the binary operator, and the ternary operator. While you were using the size of um, operator during the project and the project 2 days ago, if you read the requirements or the instruction, you will see that they said print out the size of a particular type using the unary operator. So it came from this concept under the three categories of operators in C: unary operator, binary, and ternary. So now, what do they mean? Let's talk about unary operator first. Unary operator, these are operators that requires only one operand to execute an action. Okay, so they what? They require only one operand to execute an action. And what are the types? The first one, we have the unary minus and unary addition. Just you have minus and plus, and they can be used as prefix or postfix on variables. Remember, when I was doing the put char under the string single character constants, we did something like increment and decrement. We just did a touch of it. So it came from this unary operator, unary minus and unary plus or addition. Can you see? And what you need to understand about unary operator is that only one operand, only one variable, only one constant, or only one entity is required to perform or execute an action. Just a single entity is required to perform an action. That is what unary operators deals with. So imagine you have a single variable called a, and it is performing this action minus minus a, which is called prefix decrement. And you see another one called a plus plus, which is postfix increment of a. And you can see that the sign here, this is plus and this is minus. Unary and single-handedly, they are what? Performing an operation on this variable a, and the same thing applies to this b. So just get this concept. We have the unary operator. Now we have another one, the logical not. And this is a symbol just like an exclamation mark. Now, what does this operator do? This operator inverts the Boolean value. And what is that? What do we mean by Boolean value? That is, it inverts true or false of a given expression or variable. Now, a Boolean value or a Boolean expression usually returns a true or false. That is, its output of a Boolean expression is usually true or false. So, and Boolean expressions are used to test for true or false, or they are used to test for how true, how truthful or how falsy something can be, or how true something can be, or how false something can be. For example, an expression inside this bracket, you have A greater than B, trying to tell you that is A greater than B. If the value stored inside A is greater than B, this will give either true or what? It will give either true or false. If the value inside A or B, if this expression executes by whatever value is inside, it can give either true or false. Now, let's say it gives true and we have this logical not applied to it. This logical not is going to invert it and change what if it is true in the first place, it will change it to false. And if it is false, it will change it to true. So logical not is just like it inverts the current state, the Boolean value of an expression. If it is true, if logical not is applied, it will what? Change it to false. If it is false, if logical not is applied, it will change it to true. So take home, this is a symbol for logical not. For unary minus and unary addition, these are the symbol, and this is the use case, and this is the use case for logical not. Now the next one, the third one, address of or ampersand. He said this is used for retrieving the address of a particular variable in the computer memory. You see this man, I'm just happy for everyone that's going to get the understanding about this at this point now, because there is a confusing aspect of C generally that we are still going to get to, such that if all of this concept is not known, you might be struggling. So I used to explain I was explaining something that, when you say variable, a variable has a what? A location. It has an address in the computer memory. Just know that every variable, they have a position they are occupying in the computer memory, and that position, it's like a location or an address. Okay, so there is an operator called address of or ampersand, just like and the symbol is this symbol and. Now, this operator is used for what? Retrieving the address of a particular variable. Okay, so let me quickly give an example. If we do something like this, if you do printf, if you do printf and d, and you reference and a, what does this do? This prints the address value of a in the computer memory, in memory, or in the computer memory. So just understand that this is what the function of this ampersand. When you apply the and to a variable, it will give you the address of that variable in memory. So that means for every int a that we do, what it it has been given it has been given a what? An address or location. Just get this understanding again. For every int a, for every car, whatever car a, car b, or floats, any type that is being declared, just know that it has been given an address in the computer memory. So putting down the understanding for every variable declaration, e.g. int. So get the understanding. Okay. So just understand that for every variable declaration, e.g. int a, it has been given an address or location in the computer memory. And to retrieve that address is this print, this ampersand is applied together with dot, is applied together with that um, variable. Okay. So now the last one on the unary operator is the size of operator. And yes, we have used it recently. It is used for what? To determine the size of a particular data type on a particular machine. So it is used for, probably you say size of car. I didn't give the use case. So we already know what this is, e.g. print f, you know, size of car is, and you do percent d, and then you now comma, you use the size of operator and you say car. So it is going to print the size of a car on that machine. If it is 32 bits, to give you the equivalent size in 32 bits. If it is 64, it will give you the equivalent bar. So I mean, the machine that we're talking about, it means your computer. If your computer is a 32-bit machine or 64 bits. Now, these are just what the types of unary operator. Unary minus and unary addition used for increment and decrement, and they have postfix and prefix. Unary logical notes, okay, ampersand, and then unary size of operator. Now, the second type of operator is the binary operator. So now, um, I'm talking about giving an example. So let's practicalize each of these operators. Let's see. Let's do something in our computer. Let me clear the screen. Let me enter through um um learning C. See this. Okay, I'm not going to use the terminal. It will take time for compiling and all that. Let's use our replets because of the visualization. It looks beautiful. How many persons are still online? Let me see. Wow, just two.
We can round up by 5:30 if we don't mind, since we're coming back by 9.
Okay, sure. I have that in mind already. But thank you for saying it out. So this is an example of using the size of operator. We've used that before. Let's see. We've actually practicalized increment and decrement. Let's see getting address of a variable. So getting address. So getting address of a variable. So let's get the address of each of these variables that is declared. That is x, y, z, and d. They have address. So we are going to be using printf to do that. So we can say printf, and we can say address of x, okay, and we'll print the equivalent address. So, and then add a new line. So how do we get that? We use the ampersand and the variable x. Okay. Then printf address of y. Of course, every variable declared can never have the same address till thy kingdom come. So that is necessary. So you can say ampersand y, okay, and what is it saying? Oh, sorry, thank you. You can see I didn't specify the output, so percent d, so percent d, so that it will give us what? It will give us the argument specified. So that's not right. If you are printing an address, you are to use percent p, sorry. Percent p is for printing an address. So my slide here, percent p. Percent p is for printing the address of a variable. Please, please get that. So if I say print f address of this address of y, address of z, and do percent p forward slash n, that's what, and z, and that is a float. And what's next? Okay, double, the last one. And we can say print f address of z b, and we say percent p forward slash n, and then what we reference and b. Don't forget we are testing what the unary operators, and one of them is what the unary ampersand. Okay, so unary ampersand or address of is the symbol. So now guys, if we run this guy, it should give us the address of each of these variable, address of x, and you can see they can never be the same address. So let's see what is going to print out. Look at address of x. Look at the address 0x, this string x7ff like this. Address of y, you can see that from here down to this point, this is c, this is b. You can see that it's like the last from value is changing the address. So you see this address of a thing, and point where you get to pointers, you get to how how program actually executes, how the computer really executes program in the machine, like behind the scene. This thing will become more understanding. But I'm so glad for those that are here like this, trying to see this, how to print an address, and you are seeing something like this. You have actually scaled up because you still meet this thing, and instead of it becoming so hard to understand, you will understand it to be easy. So to print address of a variable, you use the word format specifier percent p. You can always go to read more about the printf so that you can get familiar with all possible specifier you can use to print. So that is what the ampersand, the unary ampersand, used for printing the address of a variable. And it is done. How are you using it? The use case is and this symbol ampersand the variable name. Now the last, which other one can we have tested size of logical nots. Let's say, let's try that. Let's test for logical nots. Okay, so testing for logical nots. So we can do, let's test for two numbers. No, let's just write, we can do printf. So this returns true or false. Okay, okay. So let's say printf, I will say percent d. Okay, on a new line, and we are testing for, don't forget we can run some tests, mathematical tests on the printf in this way. So we want to test for 10. Is 10 greater than 5? Okay, so it is going to give us a value. Now let's put another line. We are now telling, we are using logical not now. Okay, so we can say using logical not, which is this man. So we are now saying it's in B on a new line. Now saying inverse or invert the result of if 10 is greater than 5. So whatever will be the output. Okay, before I print this, let me run 10 greater than 5 first. Let's see. Let's focus on this side. So let me run it. Now you can see it returns true or false. Now 10 greater than 5, it returns 1. And in this case, 1 is what? True. And any other value aside 2 is what? False. Now there is something here. They talk about, I want to quickly dive. Let me go before the time. Um, okay. Look at, they said what values are considered true and false in C. Let me just copy this. Okay, let me see if this guy can explain it. Look at in C programming, look at this. In C programming, certain values are considered to be either true or false. The value is 0 is considered to be false. Why any, look at non-zero value is considered to be true. This means that when using additional conditional statements or Boolean expression in C, any expression that evaluates to 0 is treated as false. Any expression that evaluates to a non-zero, now an example of non-zero, 1, 2, 10, is treated as true. Okay, so that is just the concept on true or false in C. So that is why this guy returned what? 1, which is true. Okay, look at now. So now we are using a logical not on it. So if I say printf using the logical not on a new line, now what will be the output of this? We are saying printf invert whatever is the result of this what? Boolean expression. Whatever is the result of this expression, invert it and change it. So of course we should expect 0. Okay, so now look at this, return true or false, and now 10 greater than 5 is true. Let me put this here. So 10 greater than 5 is, so is true. Okay, returns 1, new line. Okay, now this one, 10 greater than 5 is true, but invert it and invert what? The result. Okay, and we were going to say percent B. Okay, I think I just want to try as possible to explain this. So we have percent D. Now let's see. So if you run this, look at 10 greater than 5 is true. And this is what it returns 1. Returns 1. Using the logical note, 10 greater than 5 is true, but invert the result and what? It is what? It has inverted it to be what? 0. So that is the work of the logical note. It changes the the um the state, okay, of the variables concerned, of the Boolean expression, changes true to false or false to true. Okay, guys, we have had a whole load of lecture. I know we've used 2 hours 24 minutes. So, guys, a lot of things are yet to be explained. I'm just a person that usually like to explicitly explain as best I can. Okay, let's just quickly see this. We have only 3 minutes to go before 5:30. So we have binary operators. So as you can see them like this, no, the following are a list of the binary operator in C: arithmetic operators, relational operators, logical operators, bitwise operators, equality operators, commas operators, assignment operator. Now, what you need to understand is about binary operator is that they require two operand. What? They require two operand to perform an operation. So, binary operators require two operands, okay, to perform an an operation. So that is a concept. Okay. So example, e.g., example arithmetic. Okay, we have something like this. I'm just trying to instill this understanding. Something like a plus b. So the operands. And when we say example logical, so logical, you can have a and b. Okay, so just know that binary operators involve two operands. So this is what examples of the binary operators. And then we have the last one, the ternary operator, which is also known as conditional operator. This operator receives three operands and test conditions, and it tests conditions on them to produce an output. So expression one, this is the syntax. You have the first expression, you have this symbol, okay, and you have the second expression, and you have this symbol. And that is the basic use of the ternary operator. For example, what does this mean? It's saying if condition is true, question mark, is it true? Then return expression 2, or else return expression 3. So example, you have int a equals 10, b equals what? 15, and you have x. In now saying what should be x? X should be, is a greater than b? Return a, else return b. That is just the explanation of this ternary operator. It actually has three expressions. The first expression is the testing for the condition, and second expression is what? The result from the test if it is true. And the third expression is the result from the test if it is false. Let me come again. The first expression is for testing the condition. Second expression is results from the test if only if it is true. The third expression is result from the test only if it is false. Oops, lot of things to take in, lot of stuff to understand. But I'm going to break down this life into different sections and extract some of each of the section that we dealt with separate concepts. Probably you can always view them back so that you can use it to um, increase your understanding on whatever you have read so far. So the only lag behind now, we still have days, I think it's 4 days before continuing of the project. So you can still read and then reflect on what you have read, still have to talk about each of the operators. If I open this, you see a list of the arithmetic operators. You have the plus, what it does, add to operand, minus, subtract second operand from the first, e.g., subtract b from a. You know, for example, if a is 10 and b is 20, when you say plus, so it's going to add a and b together. That's 10 plus 20, that's 30. When you say a minus b, that is, it is going to subtract the second operand from the first. So minus b is the second operand, removing minus b from a, and a is 10. So you are removing minus 20 from a, you have minus 10. Now, this one asterisk multiplies both operand a asterisk b. All these things we know. Now, this one is logical, these two, because the project is coming that they will ask you to print the last number, or they will ask you to print the first number. So this man is for dividing, okay, when you are doing mathematical operation. And sometimes if you are doing a logical something, like you want to retrieve the um the first number, okay, from a set of, okay, you want to retrieve the first number from a set of operation, you use the division. This will always return the first number. This is by the side, it's just a take home, but division for dividing. And this one is called modulus, or remainder operator. It is used for returning the remainder from a division. Okay, so you have b divided by a. 20 divided by 10 logically is 10, I mean is 2. 20 divided by 2 and 10 is 2. Okay, but it is 2 remainder what? 0. So it is a remainder that this operator will always return. This plus plus increment, as we call it, and then minus minus, called decrement. Okay, it's already 5:30, 5:34. Guys, just read materials, understand the best way you can. When we come tonight, we are going to delve into it further. Thank you, thank you, thank you for joining. Thank you for staying through to the end. No knowledge is a waste, and we are going to survive this journey, and it's gonna be great. So, do you have question, clarification, or anything as we round off and say goodbye for now?